And let's start right away. So Solidity is the language that you need to know if you want to become a blockchain developer. Now, Solidity is the language that interfaces with the Ethereum Virtual Machine, and that's the software that then is going to ultimately go and interact with the Ethereum blockchain. Now, we can start learning about Solidity from the documentation in the release. It's actually very extensive and very useful. You can find it at docs.soliditylang.org. And if we explore this website, it has a lot of information that we don't have to cover right now in this introduction, but one thing that I want to point out is the version. That's very important. If you go down here, you can identify every version that they release. Right now, we are selected on latest. So we are looking at the documentation for the latest version possible, which is at this point 0.8.13, this one here. And if we go and look at the other versions, for example, version 4 here, we can see that it is actually very different. This is from a few years ago. And everything is so different. There is way less information. Now, this is to highlight that it's very important to use the latest version because they actually change syntax. So, for example, syntax that you are using on version 8 would not work if you're trying to compile it with a version 4 compiler. And we'll see more about this later. But to go and talk more about Solidity, Solidity is a high-level language. And it is taking inspiration from C++, Python, and JavaScript. So if you're already familiar with these languages, it's going to greatly help you because the syntax are very similar, especially to JavaScript. Now, where do we write Solidity? We actually don't have to install anything on the computer, which is great. And there is a great website, remix.ethereum.org, that gives you all the tools to do everything. We can write the code, we can compile it, we can deploy to the blockchain, and we can test it. We can test it in a simulated environment or even on the mainnet. So this is the Remix IDE here. What is an IDE? IDE stands for Integrated Development Environment, and compared to just a regular code editor, gives a little bit more tools. For example, if you're already familiar with programming, you might know other softwares like Atom and VS Code. Like Atom is considered a regular code editor because you can code. Yes, it gives you a few extra things compared to a text editor. It gives you syntax highlight and things like that. But it doesn't give you any extra tools that, for example, VS Code gives you. VS Code gives you a virtual terminal where you can test your software right away. And Remix is pretty much the same thing for Solidity. It has a pretty regular interface when you click on their main icon where you can add a file, open files, and things like that. If we try to get a new file here, oh, it's already open. It gives us an example for here. And this is a contract, right? Now we can code in this environment and we can also choose a compiler and compile it. And here, for example, is where the versions come into play. And then, as well as compiling it, we can deploy it and test it. Now let's talk a little bit more about the versions that I want to cover today. Here, every contract, every time you start coding in Solidity, you will start it with these two lines. This is a comment to identify the license of the smart contract that you are coding. So, to give a little bit of history here, and why the compiler likes to have the license identifier on top is because the blockchain is essentially an open source environment. And having a source of where your code is coming from is very important. And if you go and look for the SPDX license identifier on Google, it's going to bring you to the website that it gives you examples of all the different licenses that you can have. When we are going to code our things in this course, we're going to use the MIT license because it's the most open source that you can have. You can take this code and do absolutely whatever you like with it. The second line that is always going to be there is the pragma solidity. The pragma solidity gives the compiler the version of the code that you're using. For example, this line that they have here, where they have bigger 2 equal for a 0416 but less than 0.9.0 means that this contract works with the compilers from version 0.4.16 up to but not including 0.9.0. So essentially the last possible version. So we always gonna see something like this, or for these contracts that we're gonna write during this course, I am going to type something a little bit different. I'm gonna omit the first version, and I'm just gonna leave it like this, where it says, actually with the 8. This format here tells the compiler that all of the compiler version 8 work. But now you're saying, how do I choose the compiler? Well, Rubix has it already in the interface. So if we go on the compiler page, you will see here that you can pick the compiler version. Automatically, it's always picking the 0.6.6. So many times you might just want to code like this, because then it avoids this step here. But if we want to compile with a different version, we just select it. So this works with all of the version from 8. So if we pick 0.8.13 and compile it, it should work. And indeed, it shows up the little icon that says that it compiled it correctly. Now, why I was mentioning that it's important to remember which version you're using is because if we try to compile it with a compiler that is outside of this version, then it's not going to work. So now this is going to be the main environment where we're going to be coding our contract. But the second part that is very good about Remix is that it has a section where you can deploy and run transactions. This is great because it allows you to test the contracts immediately on either a virtual machine or on a testnet, and even using MetaMask on the testnet. So it's a great tool. Now, you will see how it's divided here. You pick the environment up here on top, and usually defaults to this JavaScript virtual machine in London or Berlin. So JavaScript virtual machine, VM, means that we are trying and testing the code in a virtual environment, disconnected from testnets. If we, for example, want to use our MetaMask to try, on the Rinkeby testnet, or here I have it selected on a mainnet. This account, by the way, is just an account that I use for testing, so I don't have any issues showing it here. If we select the Rinkeby testnet, you see I have some ETH on the testnet. Then, if we pick the environment of Injector Web3, then you'll see that here shows our Rinkeby network. We can even use MetaMask to deploy and try and test our transactions. So, in the end, this system is very, very good for our development and is pretty much the only thing that we're going to use. Then, in addition to these couple things, online there are so many good resources to learn Solidity, as it's a relatively new language and is very open source. This website here, tutorialspoint.com, it's very good. I use it fairly often. It has a very good layout of everything all the basic syntax that you need, and it shows many examples with many explanations as well. So I really recommend to dig through this one too. And these are the article or website here, blogx.com, and guys, Solidity is very good as well. So don't be afraid of looking out for resources and other tutorials that will help you learn. So today we went through the very basics of the language, just have an idea of what the language of Solidity means, and we explored a little bit the Remix interface that we're going to use during this course. So in the next lesson, we're going to start basically our coding. In the next lesson, you will code your first smart contract, and we are going to go over all the variables that we are primarily going to use, as well as an introduction to functions. Functions are very important in Solidity. I use a lot, so I want to introduce them early to start having a pretty good understanding of them. See you in the next one.